Hello. Today we're going to be taking a look at a new model, Qwen 3.5, running locally on the computer. And it is quite a bit of an important model because it's not the largest one that they have. In fact, the 3.5 we're going to be looking at is the smallest one that they have, the 27 billion parameter model. And the reason why this is exciting is because when you take a look at the artificial analysis benchmarks, you can see that it is 42 on the intelligence index, which means it is up there with the biggest models like DeepSeek v3.2 is actually beating DeepSeek, Gemini 3 Flash, Kimi K2.5, GLM5. It is also rated very high on the Agentic frameworks and pretty high on the coding index, especially since it is a 27 billion parameter model. There is a reasoning and non-reasoning. You can toggle it on and off. And yeah, let's just go through it and then do a bit of testing. So here are some of the highlights of the model. So this is a multimodal model that has vision as well as text. Contrasting the other Qwen 3.5 models, this is not a mixture of experts model. It is a dense 27 billion parameter model, which means that the whole model activates on every single token. There is no partial activation, which does have some benefits and drawbacks to it. One of the benefits is that it is easier to run. It is supported day one on Llama.cpp as well as LM Studio. However, it is not, it will run slower if you do not have enough VRAM to run it. Now, currently I have a 5990 graphics card, so I do have 32 gigabytes of VRAM. I can load the Q6 quantization model version of this. Now, let's continue. On the benchmarks, as you can see here that they've published, you can see that the Qwen 3.5 27 billion parameter is this second purple bar, and the lightest purple bar is 35 billion parameter with 3 billion active at a given time. So the 27 billion parameter, just keep in mind, it is the middle purple bar, and it does score quite well against all the other models on this list, which includes the Qwen 3 235 billion parameter with 22 billion active, as well as ChatGPT Mini and Claude Sonnet 4.5. So basically, this is a 27 billion parameter model. Like we said, it has 64 layers. There is a hidden layout of gated delta net. There's 256 heads. Let's see, I believe they all activate, so that's fine. One of the important things here is that the context size is 262,000 tokens, and it can be expanded up to 1,000,000. So if you have room for context, that means you can load about 5 full books into this model at 262,000 tokens, or expandable up to 1,000,000, about 20 books. You would need quite a bit of VRAM or RAM to do so. Now, although these benchmarks are great, they're not really comparing it to some of the other models that I wanted to compare it to. So I do take a look at the artificial analysis benchmarks to see how, agentic these models are. One of the more important benchmarks, I think, these days is going to be terminal bench here, as well as the agentic tool use tau squared bench telecom. So it does rank pretty high on that as well. which means OpenClaw will work quite nicely. This does score very well also on the humanities last exam, beating out DeepSeek v3.2. Now, the interesting thing about this model is it's very small and fits on one graphics card or two smaller graphics cards. So it is quite interesting to run. Now, without taking too much of your time, this model is being overshadowed quite a lot by the other releases. And I think this model should be looked into more as like a standard model to use nowadays. Now I'm going to explain in this how to download it, how to run it on your computer. The easiest way to do so is using the program called LM Studio. You definitely will not have the best performance possible, but it is the easiest way to do so. LM Studio runs the Llama.cpp backend and also supports Vision and running as a server on top of it. So what we're going to do now that we're on the Hugging Face page with Qwen 3.527b, we're just going to scroll down to the quantization section. And we need this because we can't really run the .safe tensor files that are on that main page. People usually grab the .safe tensor and then quantize it or make the model smaller so that it can fit onto more accessible hardware. So one of the better model providers or quantizers is Unsloth. We also have Bartowski here, and quite a lot of other ones, including LM Studio. Unsloth, as you can see here, has a specification of each of the quantizations, or basically how compressed the model gets. In its full size at BF16, it is 53 gigabytes, which will not fit on a 32 gigabyte GPU. So we need to compress it, as you can see, although it looks like the QA 28 gigabytes will fit. Just a reminder that we do also need to load a vision encoder or vision model in here, so it will be quite tough to load both the Q8 as well as the vision encoder. So we have to go down quite a bit. We're going to have to download the UD-Q6 KXL version, which is 23 gigabytes. And just looking at it from this perspective, you can estimate how much VRAM you need to load this model. You can see the UD-Q4 KXL version at 16.7 gigabytes is pretty good. If you have, which will fit on 24 gig graphics card with the vision encoder as well as the K-cache. Just so you know, there are also lower quantizations such as Q3KM. You would have to look at your graphics card in order to estimate how much you need. Anything below Q4 does degrade performance quite a bit, so please take note of that. Now, to download this, we can either do this directly through the LM Studio interface, or if you use Llama.cpp or any other backend, we can just download the files here. Scrolling down, you'll also see that there are M project files. Now there's 3 of them, but really you just need 1 of them. It just means that there is a bigger version of it, F32, which is the full quality, which will require 1.8 gigabytes of VRAM in addition to the model size. You can download the smaller F16 or BF16 versions, which will require 1 gigabyte so that the model can see things. Now let's move forward with just going to LM Studio here. As you can see, I have already downloaded it and tested it a bit just to make sure that it works. To download directly in LM Studio, all you have to do is click on the search, type in Qwen 3.5 billion parameters, and then go to your model provider that you like, such as Unsloth, and grab the quantization level that you want. There are, of course, providers such as directly from LM Studio, which will give you the Q6K, Q80, and Q4KM versions. There's also a size estimate of the model, and you can see that they have vision enabled here. So since I've already downloaded, I'll show you quickly how to run it and make sure to set it up properly so that your output is the best possible output. So just unloading it, we'll go to our model at the top here and then click the arrow button. Now, to click the arrow button, you can also click the manually choose model load parameters, which is very important. You select this. We're going to go ahead and put in our context length. So currently, because I am testing this, we will do it 24,000 tokens, which is about like 17,000 words or so. And the GPU offload fully offload 64 layers to the GPU. Basically, this will assign the whole model to the GPU. As you can see, I'm currently recording, so I am using 5.5 gigabytes of my VRAM, and I have to conserve that currently. The evaluation batch size here basically means how many tokens the model will read at the same time. So currently 512 tokens per read. So if you have a big chunk of text that you paste into the model, it will have to read 500 tokens at a time. You can increase this to 2048 or 4096 if you're using CPU, or you have that ability, but we'll leave this at default. The max concurrent prediction is basically there can be 4 simultaneous instances of this model running at the same time, and you can increase or decrease it as you see fit, depending on if you're using this in an agentic manner or not. We're just going to be using chat, so 4 is fine, and probably overkill, really. Unified KV cache, this is a new one. This increases the performance, of this model, makes it a bit better quality, I would say. There are also something called offload KV cache to GPU. We're basically clicking all of this, making sure that this all works properly. And the K and V cache quantization, I've also checkmarked and put it to Q8. We can also decrease it to Q4 if you really need to, but usually that decreases quality quite a bit. So we'll just use it at Q8. Now all you have to do is click model. This will load the model. As you can see, we already have vision at the bottom here. If you do not have vision enabled at the bottom, it just means that you're missing the M project file. All you have to do for that is go to your folder. You're going to right click, open File Explorer, and in this same folder, you're going to paste the M project file. So an example here, as you can see, we have the M project that you can download from the Onslaught, or as well as the quantized model. So in total, you'll have 2 files here. Now, once you do that and you relaunch the model, you will have this vision enabled model. All right, so now, although this seems like the final step, we actually have to finish initializing this and making sure that the settings are correct. Here, we have to make sure that the temperature is set to 0. Depending on what you're doing with this model, usually just text-based and creative writing will require a higher temperature. Basically, what's happening in that situation is you got the black box, which is this 27 billion parameter model. It has a logit, so once you give it a token, it will calculate the probability of the next token, and it'll output basically this logit. Then you will sample it with these settings. So these are sampler settings. So temperature will tell you how random of output you're going to be getting. Usually, if you just want the model to output, it should still stay at 0. If you want to mess with this, you will not be getting the native, native output of the model. You will be sampling it yourself. This model also says that it likes to have a top case sample of 20. So out of 20 variations of the output, it will choose the most probable one, which is 0. Repeat penalty is 1, so that means it is turned off. Top piece sampling, it is at 0.95, which is a default. And min p, we have to set to 0. Normally it's 0.05, but this model states that it likes a min p sampling of 0. That means we will not discard any of the lower probability values when we sample this. Now, as you can see here, once we generate the text, it is running pretty good at about, again, I am recording, so it's probably slower, 25 tokens per second. I think without recording, it's around 30 tokens per second. It is going to be slower than other models because the whole model is activating at the same time here. Now, you can use this model directly in LM Studio if you just want to quick chat, or you can actually use it in an external like OpenWebUI. You can use it there. And the way you do this is basically you go to the developer tab. As you can see here, this is basically a server. You'll turn on the server and it will tell you that it is casting to this URL. And then once you grab your external interface, such as OpenWebUI or any other ones, all you would have to do is set it up. And to set it up, you would go to settings, put in that URL, say it's OpenAI compatible endpoint, which denotes as v1 at the end of that. So it would be this /v1. And then you'll get your model listed here. Now, here I already tested the vision and model, so I pasted in a file. All you have to do is click upload files. And for this instance, I uploaded just a image I generated with Stable Diffusion. And all you have to do is ask it what it is or some sort of comment. It'll tell you about the image. So it understands that it is probably AI generated, has lighting effects. There's tension between violence of the weapon and fragile of the petals because there are petals here and then there's a weapon. So it can see the image pretty well. The interesting thing about this is most of it will be used for document scanning for your personal use rather than just looking at pictures. But in this case, you know, it's going to be a picture. It can extract text from a document. So if you upload some sort of PDF or a screenshot, it will extract it and then read it and then tell you all about that. So you don't have to do it OCR to text and then into this model. It natively will support it. All you have to do is copy and paste the image in here and it will be able to read it. So this is pretty good because we don't have to have multiple models extracting data, etc. Also, since this is a local model, it's important for it to have this functionality so that you can paste confidential information in here. It's not connected to the internet, unlike Google, Gemini, or any of the other online applications. This is running directly onto your graphics card and is not connected to the internet. So you can ask it whatever questions you feel, and it will keep that secret. And the second you clear your cache, you remove that history, it will not be able to remember what you talked about. So that is one of the primary uses of local models, which are open source. And yeah, it's for you to use as you see fit. Now, there are some benchmarks that I usually do on my own, and I normally don't test these models anymore because I've been using very large models such as GLM5 and DeepSeek. But because this is such a small model and it's so capable, I thought I would run it through the same tests that I run through all of the larger models. So let's go ahead and take a look first at our browser test. As you can see here, we have a, well, I guess first we'll do the butterfly test because and this is an SVG, so I'll have to get an SVG viewer. So all we have to do is control paste that. So there we go, created an SVG of a butterfly. I won't say this is the best butterfly I've gotten, but it does indeed look like a butterfly. And the main point is the wings are connected to the body, and that the antennae are also connected to the head of the butterfly, and it is an interconnected image with no missing parts. I also prompted for it to create some other things. Now, it does run relatively fast, but not fast enough that I would just do this real time. Do not want to waste all of your time. So some of the things that I did was interactive web OS. So this is a one shot. And the web OS that I created was over here. Let's take a look. I didn't really look at it yet. So if I go to full screen, this is basically very good. We have a clock here, which is the right time. We have a start menu with the same applications that are here. So if we open the notepad, so the interesting thing about this model is normally the 27 billion parameter models cannot do this kind of task. So this is very good, and the resizing works, the full screen works, minimization works. So looks like everything is working here. The calculator, so we'll do like 5 times 5 because I'm bad at math. 25, which is very good. You can resize the calculator perfectly and you can maximize it. So yeah, so the core logic of it works very well. We also have a browser, a working browser, it looks like, and on Wikipedia. And oh, that actually took me to a web page. Okay, that's very good. We'll just do cat. Wait a minute. Wait. Okay, so this is a working browser inside of a browser. This is very interesting because, as you can see, I'm still inside of the virtual OS here, and it generated an actual working browser of Wikipedia, and I can actually go to the Wikipedia inside of this browser, and yeah, so Inception, I guess. Now, the interesting about it is I don't know what to say anymore. Uh, because this is actually a working browser inside of a OS, simulated OS. Um, and there's no right click or anything. And there's also a settings saying that, okay, this is fine. Like, I can't complain about this. Everything on this browser is working very well, especially as on a quantized model. This is very good. Usually I would expect um, very large models to be able to perform this well. Okay, so let's look at some of the other tests that I did. Yeah, so one of the other tests was the Voxel Pagoda, and it basically generated a 3D render of a Voxel Pagoda. Basically, my browser freezes on this because of the amount of cubes that it renders, but I'll show you guys quickly that it generated this. Honestly, this is a very good model, especially for its size again. I still do not understand. See, it's crashing. I still don't understand how this is possible with a 27 billion parameter model. Usually I've been running like 500 billion parameter models, and even like 3 months ago, this was not possible with the 300 billion parameter models. So I don't know what happened in the last like month or so, but as you can see, this rendered, it is 3D and it works, but because it's so slow in rendering, the amount of voxels that there are, it's kind of very, very laggy right now. Now, this isn't really the model's fault. This is basically the limit of the browser rendering 3D meshes, and the way it's written is it's really driving this browser into oblivion. So the main point is, as you can see, everything is connected. You have the trees, you have the leaves or the sakura leaves connected to the trees. You also have like this gradient of varied hills, and you'll have the pagoda here. So I am not sure if any of the other buttons work, and only because I don't know if it's going to crash on me or not. So we're just going to close it out at this point, because this is basically crashing my browser. But yeah, 800 lines, pretty good. Okay, I did see other posts online saying that they've, rendered some other interesting things with it. I just want to probably just render one more thing live for you guys. And we're just going to ask it to generate an SVG of a duck working on a computer. And hopefully this is good. This is basically a live test. I haven't done this before, or this specific test, so we'll see how well it reasons through having a duck working on a computer. Now, I do not have very high expectations for it to do so or do well, but we can also look through some of the reasoning chain of thought here. So it looks like the chain of thought mimics the GLM chain of thought quite well, even though this is Qwen 3.5. You can see that there's like a step 1, 2, 3, 4. There's a self-correction step, 8 construction step, final polish, and then it goes. So the reasoning is not very verbose, which is very good. I was expecting this to be quite verbose, especially since I checked out the April 1.6 version, or April 1.6 a couple of months ago from ServiceNow, and it also placed very high on the artificial analysis benchmarks. But that thing had to really talk a lot to get any sort of performance. Wow. Okay, so as you can see here, we got a render of a duck working on a computer. It is quite simple, but on the other hand, it does look like a duck working on a computer. So I'm kind of impressed. And the other thing I have to let you know is, because of temperature zero means it will follow your instructions as closely as possible. And the reason people have very high fidelity outputs on temperature 1 is because it is not following your prompt directly, and this is why that happens. So if it is a simple prompt, it just means that you can ask it to be more detailed. Please be more detailed in the SVG, making it beautiful and aesthetic. And sometimes you can also misspell, and misspelling will actually sometimes increase the model's ability to focus on the word. The reason that that happens is it will break down that word into multiple tokens, and so it has to spend more tokens in trying to figure out that word, and so more attention goes to that word. That's basically, I would say, it is my superpower, because I misspell all the time. And even though I don't normally do it all the time, sometimes I like to misspell words for the attention mechanism to grab it. So I'll just start spelling things incorrectly sometimes, and it will perform better. So there you go. If you're dyslexic or you spell wrongly all the time, or that this might be a superpower. Okay, so it's gonna try to increase the fidelity of our SVG. Now, I also have to mention that I did test this model briefly before this on a very complex prompts, which involve shapes that um, even massive models like Google Gemini 3 cannot produce. And basically, this model will explode, meaning that it will continue to try and try and try, and then it will give you a shape that does not resemble anything. So the larger models in those contexts will still give you a shape that will somewhat resemble your um, response or request. But if it is such a complex shape that it cannot process it, it might not be able to output it at all. So those are some of the downsides of this model. Also, I do want to mention that this model, it doesn't hallucinate as much as something like Google Gemini Flash or GPT 5.2 on the AA benchmarks, but oh wow. Okay, so it did a better job. So the thing is, like, it doesn't look like much to you, but it is very difficult to write out code in order to generate an image of something because they have to plan the vectors as well as the lines, strokes, and colors all in one pass. As you can see, it does not retry whatsoever and just goes ahead with it. So this is a um, very good output. I want to show you, I guess, the same prompt with a different model, and just to show you what we're dealing with if you don't have any comparison. So I'm just gonna go ahead and unload this model here, and I have something similar, which is called um, Gemma 27B. So it's also a 27 billion parameter model, but it is quite old. So unfortunately, well, quite old is like, what, a year old? No, probably not even a year. It is also vision based from Google open source models. So the model itself is very good as well. I am not quite sure of all the settings for this specific model. I'm just going to be showing you the, I guess, difference of um, the capabilities and how it increased over time, this model. So here's Gemma, it's, done. This, let's look at it. Yeah, so that was Gemma 27B. As you can see, this doesn't look like a duck working on a computer whatsoever. And yeah, normally people will say, yeah, this is too old, there's nothing to compare it to. So we can also compare it to 4.7 Flash. GLM 4.7 Flash literally just came out maybe a couple of weeks ago. So this is probably a good comparison. Also, it is, I do have, let's see, a vision. This is a bit too small. Let me get something. Let me get something. Hold on. I do have quite a bit of models here, as you can see. So this is the 4.7 BF16 model. It is basically the best quality you can get it at. But yeah, it's going to be quite troublesome to run this on the computer because it is 64 gigabytes at BF16, so full quality. And the reason I was trying to get it to full quality is because I couldn't really get it to generate the same quality as this 27 billion parameter model. So I basically was struggling with it for quite a bit of time. So we're going to just drop that in here. Same prompt, which is please generate an SVG of a duck. Okay, that's the reason I did not let you guys witness all of that suffering and looking at the generation of the WebOS, because they would have taken much longer to show you guys. Okay, so here we go. We're just gonna copy and paste it into here. Now, as you can see, there's always this issue with some of the models where, because of their MOE or something, the duck build doesn't align, and you know, some of this, you can see that it can probably be good if it lines up, but it doesn't line up. So, and then just so you remember, this is a BF16 model. This is the highest quality that you can get, and it's 56 gigabytes in size, right? So this is what we're dealing with in terms of quality. So got this versus this. So this one looks a lot better, even though it's simple. The nose is in the right place, the eyes are in the right place. You can see the chair, the screen, the table. I don't know what that is actually. But yeah, so there we go. That was my review of the 27 billion parameter Qwen 3.5 model. And honestly, I hope you guys check it out. Let me know in the comments what you guys are using this for. If you try it on OpenClaw, is it going to be able to run that whole stack? Honestly, I haven't tried that yet in my personal experience. But yeah, let me know in the comments what you guys think of this model, or if you guys are waiting for using any other kind of model. Thanks a lot, and see you in the next one.